Good afternoon, everybody. Oh, no, it's morning here still. And we're back in lockdown. So, we're bringing out the videos again. Hopefully this comes across okay. And today we are looking at... Get my pen going. Where am I? Maximum flow problems through a weighted directional network. So, it's about... The easiest ones I use all the time are things like water going through a system. Okay, certain pipes can take a certain amount of water, and that means that to know how much water, for instance, a system can transfer, we need to do some calculations to be able to calculate that. Okay, it's pointless having all these massive pipes and then a really small pipe somewhere because it upsets the system. So an example of that is if I have two pipes connected and they look like this, and water comes in here and it goes out there. This one here might have a capacity of 10 litres a minute. This might have, I don't know, 7 litres a minute. Right. The total capacity of this system for moving water is 7 litres a minute. So what I'm getting at here is the key to this is the minimum amount of water, or the minimum capacity of any one point in a system is its maximum flow, right? And that's what we use for these flow problems. Okay, so where's my rubber gone? Yeah. Righto. So looking at this on the left of the screen, we can calculate it by using cuts. Okay, and the cut is simply just taking it through, and that cut there, if we called it cut 1, we can calculate the flow. Okay, the flow for this cut is the amount of water that both of those pipes can take through. All right, so that might have a flow of, well, it does have a flow of 19. All right, and then but that's not the only possibility. So we need to find all possible cuts, all right, and calculate those. Let's call that cut 2. Cut 2 has a flow of 147. All right. Now, you might be saying to yourself, that actually should have a flow of 12. This here isn't counted. All right. So we're only counting the edges that flow from the source to the sink. So source, and this is our sink over here. All right. This flows in the opposite direction. So the water has already got past our cut point there to come along from B to A. So that won't be covered there. All right. So it's important to know that we're only counting the edges that flow from the sink to the, from the source to the sink. All right. So cut 2 has 7. Then we can go, I'll do another one. I can see one up here. That might be cut 3, and cut 3 is 1, 3, 4, and 8, so that's 12. I can keep going here. I've got that. I can go 1 via here. Go around there. That's cut 4, and cut 4 equals 1. We've got a 5 there, so that's 6, and that's 14. 8. Again, we're not counting this 5 up from B to A. I'm counting the 5 from B to T. Might be the garbage truck in the background. And then I can see another easy cut there. C5, cut 5, and that's 3, 5. That's 9. Right. I think I've covered most of it. I can see one. Here, cut 6, and that equals 11. That's going the opposite way. That equals 14. Okay. And out of anything else, I can see. I've got to make sure I'm not doing the same one twice. I can see one coming here, I think. Okay, C7. And that equals cuts. We've got 1, 4, 7. Alright, I think I've covered all of my possibilities. There could be others. I'm pretty sure there's not any more that that are lower than my lowest at the moment. So you can see I've got two cuts that equal 7, and as I explained earlier, the maximum minimum cut, okay, equals the maximum flow. So that what we're saying there is my minimum cut is 7, so this system has a maximum flow of 7. It might be 7 litres a minute, it might be 7 gigalitres a minute, who knows? And that's because of this earlier example. Okay, so we've got 2 pipes. Okay, one's 10, one's 7. I cut through this one, that's 7. I cut through this one, that's 10. Okay, my minimum cut is 7. Okay, so my maximum outward flow is 7. Alrighty. Now the next one is a multiple source job. So when we have more than one source going to sink. For this one we have to, I'm not going to do this one in full, I'm just going to explain the concept. For this one we have to consider both of them separately. Alright, so we cut each one of these off, source to the sink, separately. So for instance, I would use this, I'll do this separately. Now, I'm cutting through here first, so I might say we've got 1200 there. I might try and cut through here. Okay. I don't need to count the 200 because it's not going to this sink, to my sink up here. Okay, it's going to this one down here. So I might say that's 700. I might find that I can go through here, and that might be, well, not might be, that's 700 again. Put the other 0 on that. And I can go through here. So all of those look to be 700 as our lowest cut. Then I would need to consider this one. Okay, so I can put a multitude of cuts through here. Through here, can cut through there, okay, and add them up. Then you would add up both of those and find the total capacity of the system. So the lowest figure from your source 1 and the lowest figure from your source 2. And if we do a quick inspection of this, we can see got 700 here. We've got 200, 200, 100 is 3. That's 6. That's 700 here. And down here we've got 7. That's 800. And we can go on. Look, other cuts are possible, but right now I think I've used up all of the cuts that are making it. I think that's 900 just quickly. So my min cut there is 700. My min cut there is 700. So 700 at each outlet. Okay. Now, depending on what the question's asking you, you may have to go, what's the total? So obviously you add them both up. But that's the basics of it. So it's a very inspection-heavy task. But that is how you do it. Find the minimum cut. Okay, cut it, add up all of the values across that cut. So like I said here, that's 700 right there. As a 300, a 100, and a 300 as the edges that it's cutting through. And that gives us our value 700. So hopefully it helps. Hopefully I've kept it nice and short as well. We will see you next time. Have an excellent day. And that's me. Cheers, gang.